Exam 1. Multiple choice. 1. Which of the following is not an intensive physical property? ANS is mass. 2. Which of the following has the least kinetic energy? ANS is ice at -20 C. 3. Which of the following has 4 significant figures? ANS is 1.800103 L. 4. Applying significant figures, what is the result of the following operation? 12.19.52/4.563 equals, ANS is 0.57. 5. An atom of manganese 55 contains, ANS is 25 protons, 30 neutrons, 25 electrons. 6. Which of the following is the lowest temperature? ANS 32 F. 7. Which of the following contains the smallest number of atoms or ions? ANS is 16.00 G oxygen or 55.85 G iron. 8. What is the mass percent of phosphorus in Ca3(PO4)(2)? You take the mass of P divided by mass of Ca3(PO4)(2) and times that by 100 equals ANS 19.97. 9. In the following reaction, Cu(S) plus 2AmGNO3, Ac, 2AmG(S) plus Cu, NO3, 2, Ac. ANS is Cu is oxidized to Cu2 plus and Ag and is reduced to Ag. 10. Which of the following compounds contains S with the highest, most positive, oxidation number? ANS is SO4 to the negative square root. Written test 1. 1. Feet to equals feet times 12 in over 1 in times 2.54 centimeters over 1 in times 10 millimeters over 1 centimeter times 1000 over 1 millimeter to get ANS. 2. Celsius to Fahrenheit equals 1.8 times C plus 32. From Fahrenheit to Celsius 0.5 times (F, 32. Celsius to Kelvin equals C plus 273.15 and opposite to get Kelvin to Celsius. 3. To calculate atomic mass, so atomic mass equals sideways M inside is M isotope (percent abundance isotope over 100 parenthesis). So put the atomic weight in a mu in for atomic mass equals the first M element parenthesis percent abundance of that first M element over 100 parenthesis plus the second M element parenthesis percent abundance second M element over 100. Then we add the percent abundance equals 100. And have percent abundance first M element equals 100 minus abundance second equals 100 minus an abundance amount in problem equals ANS. Then have the atomic weight in a mu equals parenthesis first M element parenthesis times parenthesis ANS over 100 parenthesis plus atomic mass of second element times abundance in question over 100. So M second element equals atomic mass of element minus what the equation of second mass times abundance over 100 equals ANS. 4. Millimeter to centimeter equals parenthesis millimeter times 1 centimeter over 10 millimeters parenthesis to the root 3 times 11.3 G over 1 centimeter to the root 3 times 1 mole of element over the atomic mass G times 6.022 times 10 to the 23 root of element atoms over 1 mole of element equals ANS. 5. When an element has Roman numerals in the first element, it goes into the second element. If the element had it has 3 oxygen in element and inside parenthesis times 2. Di has 2 in that element. Tri has 3. Perchloric acid equals HClO4 Ac. Tetra has 4. Oxide has 2. Hexa has 6. Ammonia equals NH3. Example: aluminium sulfite equals Al2 parenthesis SO3 parenthesis 3 and lead parenthesis 4 carbonate equals Pb parenthesis CO3 parenthesis 2. 6. Complete and balance equation is you add the first element with the second element in the second compound for the first product and then put together the second element in the first compound with the first element in the second compound. Then you balance both sides of the equation, like if one element has 2 and the other doesn't, you put 2 on the other side. Also 2HCl equals H2S gas because H will have 2 amounts and NH4Cl plus KOH. You will break away one H from NH4Cl and put it with the OH to make H2O. 7. Conventional equation equals balance equation with product side of the 2 element has AQ equals the product having solid and AQ. Then total ionic is where the net ionic of the element except the solid, so Li down the row equals +1 and AU, CU, AG. B down the row equals +2 and MN, FE, CO, NI, CU, ZN, CD, PT, HG. CR, FE, AU, AL, GA equals +3. Then N and P equals -3. Also, O to SE equals -2. Next, F down to I is -1. And He down the row equals 0. Net ionic takes away common net ionic elements to get the element that would get the solid in the product. Then observation is most likely to make a precipitate. 8. Limiting reagent and calculate theoretical yield equals first millimeter of the first element compound equals atomic weight of first element plus atomic weight second element and plus the possible third element's atomic weight. Then do the same to the other element and the solid compound. Next, you take the weight for each element in the question times 1 mol of the element over the atomic weight we got for that element before times 1 mol of the second compound over the amount of the first compound element times atomic mass of the solid compounds equals ANS. Then weight for second compound given times 1 mol of second compound over atomic weight of the element we solved for times 1 mol of solid compound over 1 mol of second element compound times atomic mass of solid compound we solved for over 1 mol of second element compound equals ANS. So the limiting reagent is the smallest amount compound element and theoretical yield equals the number for the compound of the reagent. Next, percent yield equals actual yield over theoretical yield time 100. So actual is given in question by stating amount is recovered over the ANS for theoretical times 100 equals ANS. 9. Molar concentration equals amount dissolved over ml created times 1 mol of solution over atomic mass of element in G times 1000 ml over 1L equals m of element. There is a new molar concentration, so M1V1 equals M2V2, so we have M1 equals ANS we got earlier. V1 equals the amount that is transferred in ml. And V2 equals second ml in problem. So, M2 equals M1 time V1 over V2, so we plug the amount in to get ANS. 10. Empirical formula for a compound equals take the grams of the two compound elements and times by 1 mol of that compound over molar mass of that compound, then times by 1 mol of the first element in that compound over 1 mole of the compound. This will get just the first element of each compound in moles, then times it by molar mass of that element over 1 mol of that element equals ANS in G. Then you have all but one element in problem above, so you solve the mass of that element by taking the sample mass minus the mass we found for the two other element we solved for, will get G of that element, and we should also find out the moles, so we time the G of the last element we calculated by 1 mol of the element we are solving for over molar mass of that element. Then we divide all the elements by the smallest element ANS to get the amount of each element in the compound and round the ANS when we divide if needed. Part B. What is the molecular formula of the compound? So we have molar mass of EF equals parenthesis the amount of the first element times the molar mass of that element parenthesis plus parenthesis of second element amount times molar mass parenthesis plus molar mass of the last element equals ANS. So the ratio molecule molar mass or EF molar mass equals the determined G over mol divided by the molar mass of EF we found equals ANS. So molar formulas is ANS we just found of the empirical formula we solved for earlier.